In letter B, determine the resulting stress of the top fiber of the beam at the fixed end if the center of the gravity of the strand is 75 mm above the neutral axis of this section. Okay. In order to find the stress at the top fiber of the beam, we need to get first the moment. Now, the formula of the moment is weight times length over 2. So, as you can see, 8 kilonewton per meter is the weight and 8 meter is the length. 8 times, which is 8 times 8 times 4. If we calculate this, we can get 256 kilonewton meter. Now, there are two cases in finding the flexure at the top fiber of the beam. Okay. There are two cases, so the cases are due to the bending caused by the load of 8 kilonewton per meter and due to the pre-stressing and moment. So first we need to get the fiber, the flexure at the top fiber in due to the bending caused by the load. Now, the formula for the due to the bending cause is F sub top is equal to M, which is moment, and C, which is centroid, over I, which is inertia, moment of inertia. Okay. M is 256, the moment, and the centroid is 600 times 600 minus 362.5 times 10 to the 6th power. Over the inertia, which is 27.541 or 541 times 10 to the 8th power. Sorry for the noise. Now, if we will calculate this, we will get we will get 22.076 megapascal. Now, due to the pre-stressing and moment, we have the formula F sub top is equal to negative P over A minus MC over I. If you can remember, the P is what we get in the problem. It is the pre-stress force, 650 kN. And A is the total area, which is 80,000. And for the MC, we have the 650 times 0.75. 0.75 came from the problem. And times the C, the centroid, 600 minus 362.5 times 1,000 over the inertia, which is 27.541 times 10 to the 8th power. If we will calculate this, we will get 2 will get negative 8.167 megapascal. Now, we will need to combine these two to get the stress at the top fiber of the beam. So, F sub top is equal to 22.076 minus 8.167. We need to remember that if the outcome of these two values is positive, then it is tension, and if it is negative, then it is compression. Now we have 13.91 megapascal, which is positive, then it is tension. Let's proceed to letter C. The letter C is, in finding the eccentricity, it is somewhat alike in the letter B. It also has two cases which is due to the moment and due to the pre-stressing force. Now first, we will get the moment, which is same in letter B, the 256 kilonewton meter. Now, the flexure on the top due to the moment, we have the formula F sub top is equal to moment times centroid over inertia. Now, moment is 256 times 600 minus 362.5 times 10 to the 6th power over inertia, which is 27.541 times 10 to the 8th power. Now, if we will calculate this, we can get 22.076 megapascal, which is the same in the letter B. As you can see, it is the same. Now, let's proceed to the due to the pre-stressing force. In due to the pre-stressing force, we have the 650 kN, and we are finding the eccentricity, so we will add the E at the end. You can see 650 times 10 to the 3rd power E. Okay. For the formula, which is same with the letter B, we have the negative P over A minus M times C over I, which is P stands for pre-stress force over the total area, which is A. Okay, we have the 650 times 1000 over 80,000, and M stands for the moment. 650 times 8 times 600 minus 362.5 times 1000 over 27.541 times 10 to the 8th power, which is the inertia. Now, if we will calculate this, we will get the negative 8.125 minus 0.056 E. Let's assume that tension is equal to compression to produce zero stress. Now, we will have 8.125 plus 0.056 E. Let's combine these two values to find the eccentricity. Assume tension is equal to compression. Let's combine 22.076 equals 8.125 plus 0.056 E. Now, we can easily calculate this na And we will get E is equal to 248.89 millimeter. Thank you.